Good morning. Today in this video, you are looking into classification. What is a classification? And then what are the classification techniques? Here, the classification techniques are: what is a decision tree? How can you form the decision tree? And then what is the base classification? How can you use the base classification for different data sets? And then what is the rule based classification? And then these are all different methods for the classification. And then back propagation is one of the method. That means you know about the neural networks. And then k nearest neighbor algorithm, and then genetic algorithm, rough sets, and fuzzy logic techniques. These are all classification technique. One of the another technique here is a prediction technique is there. Here a regression. Here what is a regression? What is the difference between the non-linear regression and then linear regression? That means you will know about the all these topics here. Here comes to topic. Okay, what is a classification and then prediction? Here classification. What is a classification? Classification is a supervised learning here. Here, what is a supervised learning? Here, supervised learning is one of the machine learning technique here. The machine learning technique divided into three categories. That means most probably two categories: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning here, the classification is a supervised learning. Here, with the help of training data set, the system will learn something. That's called here supervised learning. Here, just like with the help of teacher, the student can learn something. That's called here supervised learning. Here, unsupervised learning. What is an unsupervised learning here? Without teacher, student can learn something. Here, that is a unsupervised learning here. Here, classification is a uh, supervised learning here. Here, in this case, you can predict the input and output variables. Here, that means you can predict the input and output variables. And classification, what is the necessity of classification here? The classification used to dividing the data into different groups. Here we have some data is there. For example, employee data, student data. Here you are going to dividing the data into different group, but not necessarily similar properties, is called here classification. Here that means the classification predict the categorical labels here. Here class labels, those are all called as a class label. This type of classification applicable for the discrete data and the nominal data. And then classification predict the categorical label. One of the main important point in this case here is a that means always it will identify the classification, whatever may be the classification technique, either decision tree or naive Bayesian classification or something. Any kind of classification technique predict the categorical labels. That is called here classes here. Here it classifies the data, construct the model. That means it classifies the data based on a training set here. And then what is the thing in this case here? Here you are taking the training data. Here you are giving training data to the algorithm. Here this particular algorithm predict the class label. That means this algorithm identifies some model. The models you call it as a set of rules. Here it will identify the set of rules. Based on that rules here, and then next you will give a testing data to these rules. The rules we call the main intention of this classification is a identification of different rules. That means identification of model for the system. That is called here the main intention of classification here. And then the classification predictions are two forms of data analysis that are used to extract the model. Here I am telling you model in the sense rules. Extracting the model describing the important data classes or predict the future data trends. That is a something about the classification. Here the classification is two steps process here. One is a build classifier model, or this is called this one is a build classifier model. Another one is a use classifier. Use classifier for the classification. Building the classifier. First model, how can you build the classifier? Second model here is a use classifier for the classification. Comes to the first model here, how can you build the model here? Here you are building a model based on a predefined classes here. Here that means describing a set of predefined classes here, and then each tuple is assumed to be belongs to the predefined classes. Here for example, any tuple here, for example, employee number, employee name, employee salary, employee in that case here, employee salary, in that case employee number value, employee name value, employee salary value, this is called here row. The row, each row is assumed to belongs to the predefined classes. Any all rows here, if you want to write any row here, that belongs to the predefined class as determined by the class attribute. Here it is called here learning phase. Here the build classifier model is also called it as a learning phase. Here divided into two phases here, learning phase as well as a classifier phase. It is called it as a learning phase or training phase. Here it is called it as a learning phase. Here why it call it as a learning? Here the model, the algorithm learns something from the learning. Here it predicts some rules. Those rules are called as a models, and set of tuples used for the model construction is called it as a training set. That means here you are using the number of rows for the data set. Here always uses a train, that is called here training set. The system, the algorithm takes a set of tuples for learning something, that is called here training set. Here model is represented as a classification rules. Here you are getting the model, that model you call it as a classification rules or decision tree or mathematical formula. That is a thing. Here in this case here I am telling you some, I am taking the some training data. Here the training data like this: name, rank, years, and then tenure. Tenure yes or no. Here name, for example Mike, the assistant professor. Yes, similarly Mary, assistant professor, 10 years, yes, tenured. That means will you get the promotion or not, like that, tenured. And then Bill, professor, 2 years, yes. If you having the 2 years of experience, he is eligible to tenure. And then Jim, associate professor, he requires 7 years, yes, he is tenured. Here they associate professor, 6 years of experience, but no tenure. Here in this way I am giving the training data to the uh, classification algorithm. The algorithms here is a decision tree, rule based classification algorithms are there. Decision tree, some of the decision tree algorithms are there. C4.5 one of the algorithm, ID3 algorithm, and then CRT cart algorithm. You are using any kind of algorithm in this case here. Here J48 one algorithm. Here this algorithm learns something from the training data. From the training data the algorithm learns something, and then it produces a model. It produces a model. Here the model you call it as a classifier. The model you call it as a classifier or a model, or it produces a set of rules. Here if rank equal to professor, rank equal to professor, or years of experience greater than 6, then tenured S. Yes, sir. In this way, it from the training data set, it will produce a n number of rules. Here you have to give a training set as a you have to consider, you have to complete the all rules, like you have to take the data set more number of attribute, more number of tuples, then only it will produce n number of rules for the training data set. Here that is a simple information about the learning phase. Here the algorithm learns something, that's why it is called it as a learning phase. Algorithm learns some information, that is a training uh, learning say, that is called as a model construction. And then comes to the second phase. Here is a classifier phase. Here here, which is used to estimating the accuracy of the model. Here you constructed the model in the previously, here whether this particular model works properly or not, that kind of information estimated by this classifier phase. Here it's a known labels, that means known label of the test sample is compared with the classification result from the model. Here that means accuracy rate is percentage of test set of samples that are correctly classified by the model. Here in this way the accuracy is acceptable. Here use the model to classify the data tuple whose class labels are not known. Here you don't know about the class labels. Here the class labels here comes to here. Here the class label is a tenured, yes or no. Here for example I am giving a Jeff. Jeff is a professor and then years of experience 4 for the testing data. Jeff Jeff is a one of the professor and then years of experience. No. Here what is the model prediction or classifier? Here you are giving the testing data to the classifier. Classifier is called as a set of rules that is called here model. In this classification technique, the identification of model is the main important thing. Here the main important thing here is how to identify the classifier. Here based on the classifier only you will predict the class label. Based on the classifier you will predict the class label. Here I am giving the training data as a Jeff and then professor and then years of experience 4 years, then whether he is eligible to tenure or not. Here yes, that means this algorithm, this rules produces a yes tenure. Here this is a testing data, that means we are giving the testing data classifier and then produces a result. That is called here classification technique. Here it is a 2 phases. The second phase here is a use the model. The first phase is here is a learning stage. In the learning stage you are taking the training data. Here comes to the learning stage, you are taking the training data. Training data will give to the algorithm produces a model. And then comes to the second phase here, classifier phase. That means use model to the in prediction. Here you are giving the testing data. Here you are getting the result as an unseen result. Here yes or no. Here for example, simple example for this one. Here TID, refund, marital status, and then taxable income, and then seat or no, whether it is seating or no. Here this is called here training data. That I am giving the training data to the learner classifier. Here this produces some model. Here this produces some model, and then again I am giving the test data. Here test data, refund no, I am giving the test data like this, no. Marital status yes, marital status single, and then income, taxable income 75k. Whether cheating status here, no cheating or yes. That means it will predict the yes or no information. For example, from this one is a no, single person. Here comes to the third one, a single person. Here taxable income here 7k. Here yes, here is s. Here in this way it will predicting the class label. That is a simple information about the model construction using the that means in this way this is the construction phase and then learning phase. Here learning phase you are taking the training data, and then construction phase you are taking the testing data. You are testing the you are giving the testing data to the model, you are giving the training data to the algorithm. That is a simple information. Here the classification divided into the classification technique, different classification technique. Decision tree is one of the technique, base classifier is another one of the technique, and then rule based classification is another technique. In this way different techniques are there here. And then one of the prediction, the prediction technique is a regression. Regression is one of the prediction technique. Here Here comes to the classification, different techniques. Here you will discuss about the only decision tree, Bayesian classification, rule-based classification, and then some of the prediction techniques. Here comes to the classification, prediction issues are there. Here some issues, two kinds of issues are there. Preparing the data for the classification and prediction. One of the main issues here is you are taking the data set. Here, the preparing the data set is one complex problem here. How can you preparing the data set here? Here, whether you are using the numerical data or categorical data or some of the discrete data and continuous data. Here, that is a main important. Other one is a comparing the classification and then prediction methods. Here, the another important issue in this case here, how can you comparing the comparison of the different classification and prediction methods, that is the issues in this case here. And then preparing the data, that means at the time of preparing the data, here in the preparing the data for the classification and prediction, you have to perform the data cleaning technique. Here you have some idea about you have a great idea about the data cleaning techniques in a previous videos. Here from the previous videos you have some great idea what is the data cleaning here. The data cleaning in the sense, here real world data consists of incomplete data, inconsistent data, and then noisy data, and then redundant data. You have to remove in such kind of data from the data. That is called here data cleaning process here. Here that this refers to pre-processing the data in order to remove or reduce the noise and treatment of missing values. Here removing that is called here removing the noise here. Here in this way we will preparing the data here. First thing here, you have to remove the noise from the data, and then relevance analysis here. The second point in this case here, the many of attributes in the data may be redundant data. That means how can you remove the redundant data here? Correlation analysis. Some of the redundant data removed by using correlation analysis. Not all redundant data here. Some of the data only. The correlation analysis can be used to identify whether any two given attributes are statistically related or not. Statistically related, that is a relevance analysis. And then data transformation and reduction methods, transforming the raw data into understandable data. One of the, that means in this case you have some idea about the different techniques for the data transformation here. And then reduction methods are there. Compression method, that means reducing the size of the data without changing content. That is reducing size of the data. That is a reduction techniques. Here in this way you have to preparing the data here. Here other important issue is a evaluating the class methods here. Here issue of evaluating the class methods here. Here how can you evaluate the class methods based on accuracy, speed, and then that means which method you are taking. Here if it is a good accuracy, that means you will take that kind of method. Speed, not only accuracy, speed, robustness, scalability, interpretability. Here interpretability. Here these are all different methods here based on if it is a the method works with this all factor, then only you will selecting that method or that algorithm. Here some of the application for the classification here. Credit approval, that means whether this particular person paying the loan or not. Here you have to estimating by using classification technique here. Here target marketing, medical diagnosis, fraud detection. Here you are giving the loan, you gave a loan to the person. Here that particular person again pay the loan. That's kind of information. And then weather forecasting, stock market analysis. And the main intention here is a predicting the stock marketing. That is a applications here. Yes, the classification techniques here. One is a decision tree, already explained, already Bayesian classification, rule-based classification, and then prediction. Here comes to the first one, decision tree. What is a decision tree here? Decision tree is a flowchart like a structure here. Here the where each internal node denotes a test on an attribute. Here how can you represent the decision tree here? The decision tree just like a flowchart like a structure. What is the flowchart here? Pictorial representation of program here. Like that, here the flowchart consists of different. For example, the rectangle box used for some purpose, diamond box used for some purpose, and then ellipse used for some purpose. Like that, the uses a different notations. Similarly, here also decision tree takes a different notation for representing the um, um, class labels and then attribute. Here internal node test on a attribute. Here it indicates the test on attribute, and then each branch. Here branch in the sense the result of a test, the outcome of a test here. And then leaf node is the terminal node or leaf node. The leaf node indicates that class label here. Here the leaf node indicates the class label here. Here this decision tree induction is developed by Ross. Here decision tree algorithms are known as the ID3 algorithms, iterative decotomizer, and then C4.5, an advanced version, the advanced version of mm, advanced version of ID3, and then CRT cart is another one of the algorithm. That means J48. You will use the different kinds of algorithm for developing a decision tree. Here the same decision tree classified in the form of tree structure. Here it's having the decision node. The decision node is called as the internal node. Here the test on a single attribute value. Leaf node indicates the value of the target attribute, and then edge. The edge in this test here split off one attribute. Path is there. That distinction of the test to make the final decision. Here it is some algorithms you are using. That's ID3 iterative decotomizer. ID3 C4.5 advanced version of the ID3, and then CART cart. These are all different algorithms for decision tree induction. Here each algorithm uses an attribute selection measure here. Here what is the attribute selection method here? That means you have a data set is there. I want to select in one attribute. Here which attribute I am selecting first, after that which attribute I am selecting next. Here that is a to select the attribute tested for each non-leaf node in a tree. For that purpose you are using these different algorithms, and not only those algorithms, here some of the pruning algorithms are there. Here in order to improve the improving the accuracy, you will use a pruning algorithm. Here what is the pruning here? Removing some of the branches, removing some of the information. Here by that means you will remove the tree branches reflecting the noise in your data. Here there is a noise in your data, that means you have to remove the such kind of branches here. Here for that purpose you are using the some of the algorithms, and then several scalable algorithms are there. And scaling here the SQLite queue, and then sprint, and then rainforest. Here these are all some of the algorithms for scalable algorithms. Here what is another important point here is why you need of a decision tree here. What is a decision tree? Why it is useful? That means you are using the for classification. Why I should use a decision tree here for this? Here decision trees are powerful and popular tool for classification and prediction. These are all powerful tools here. That means any person, that means you don't have any programming knowledge, that person can easily understand the decision tree. That's why it is a very powerful tool. And then decision trees represent a rules which can be understood by the human, and then used in a knowledge system such as database. Here in order to taking the decisions here from the database here, that means one of the machine learning approach here. The decision tree analysis is one of the machine learning approach. That's why you are using the decision tree. And then key requirements are there. One key requirement here is a attribute value description, predefined classes, sufficient data. Here that means attribute value description here. Here you have to give some attribute values. Here the properties are attribute. That means the collection of attributes. That means how to fix the for any data set, how to fix the collection of data set here. The collection is here. The collection of attribute. That means how many attributes required for this one data set. For example, employee data set. For the employee data set, you have to measure the attributes, and then predefined classes here. Here, before that, you have to take the predefined classes. Here, whether, for example, whether buying the computer or not, for that one, what are the predefined classes? Here, for the predefined, yes, buying the computer, no, buying the computer. Or you will collecting the predefined classes, and then you have to give a sufficient data to the training cases. Enough training cases should be provided to learn the model here. You have to give a more number of rows, not a more number of rows, sufficient data. You have to, in all cases, you should cover the all cases in a data set. In this way, you have to give a training data. That is a requirement here for the designing the decision tree. Here, the training data set is a very important. You have to give a sufficient data for the training data set. Then only it will predict the class label for the testing data. Here, the classification by the decision tree induction consists of decision tree induction, attribute. That means second point here, attribute selection measures. Here in the attribute selection method, information gain ratio, Gini index is there. Tree pruning methods are there. Scalability and decision tree induction. Here, this is some decision tree indexing. Here, what is a decision tree induction here? Here, the decision tree induction is a learning of decision tree from a class label training tuple. From the training tuple, learning process here. The decision tree induction is a learning process. Here, you know the decision tree, and then decision tree classify the instances. Example, starting at the root of a tree. Here you have to starting at the root of the tree. That means you have to predicting the root here. The main important thing here is predicting the root. Here, how can you predicting the root here? For predicting the root here, you have a different, not a root here, internal nodes. For predicting the internal nodes here, you have a three different methods are there. Here one is a information gain ratio. These methods are attribute selection. That means internal node or root node selection measures. Here, with the help of these methods here, root select and moving to the leaf node. That is a decision tree induction methods here. Here, the decision tree perform a classification without much computation. You are not performing any calculation on a decision tree. You are generating the different branches and then different internal nodes. Here, how can you predicting the internal node? Which node you are using first? Which node you are using next? In this way, you have to. That means there is no computation here, no calculation here. It handles the continuous and categorical variables. Here, categorical variable. For example, I am telling you age. Yeah, numerical variable. The numerical one thing. Best example age. Age for the numerical variable. I am taking the age as a 31, 41, 51. Like that. I have 41, 51, 53, 54, and then up to 100 years of human life. That means you may take the numerical value. Here, what is a continuous variable here? The continuous variable here is a, for example, age 0 to 20 years. That's a call it as a youth, or 0 to 30 years. Here, youth, and then after that 30 to 40 years of age, that is a middle aged person. 40 to greater than 40 years, that is a old age person. That is a in this, that is called here 0 to 30 years of age, and then 40 to 50 years of 30 to 50 years of age, greater than 50 years of age. That is called here continuous data. Here comes to the categorical variables. Categorical variable, how can you represent categorical? For same age, how can you represent categorical variables here? Young, youth, middle age, old age. Here, that means the categorical label having the finite number of values. The values for the attribute here finite. You can know the values, finite number of values. That's called here categorical label here. Here it provides a clear indication of which field are the most important and for a prediction or classification. Here some the steps for the decision tree construction. How can you constructing the decision tree? Here the first, if you want to constructing the any tree, you should require root node. How can you get the root node here? After that, you have a internal nodes. Here you have to divide it into different branches. How can you divide in the branches here? After that, you have to finally identify the leaf node here. How can you identify the leaf node here? Here, the first step here in this case here is what is the first step here? Select the best future as a root node. Best future. How can you identify the best future here? By using different techniques are there. Information gain. One of the technique here, information gain. With the help of information gain, I identify the best future, and from the best future, I can identify that this is a road. After that, next best future. That's called here next internal node. After the next best feature, next internal node. After that, finally apply the class label. That is a leaf node. Here, after partitioning by this future, select the best future. That means with respect to the subset of the training data, with respect to the subset here. Here for a subset, training data divided into two or more parts here. Here from the parts here as a root node of this subtree. For the subtree root node here is for the entire tree, it is the internal node. For entire tree here, you call it as the internal node here. And then recursively until partition become the pure or almost pure. Here until finding the leaf node, until finding the class label, you have to perform in these partitions. That is a step-by-step process for the decision tree construction. Once again, repeat here, the step-by-step, select the best feature as a root node of the whole tree. After partitioning by this feature, select the best feature for the subtree. That means best feature in the sense you have to identify the internal node. In this way, you will find the here you have a data set is there. The data set consists of attributes: age, income, student, credit rating, and then class by the computer or not. Here the age I am taking the age attribute. That means here I am taking the categorical data for age or anything. Here I am taking the categorical data. These attributes are called as a all are categorical attribute here. Here each and every attribute have the finite values, not an infinite. For example, numerical data is having the infinite data here. If for example age 1 2 3 4 5 up to not having the infinite age. Here categorical data: youth, middle age, senior. These three are the middle age person, senior person. Only these three labels I am taking here. For the age, youth. And then income, comes to the income here. Income highest, medium, low. Only three labels here. And then comes to the next one here is a student. Whether this particular is a student or not. Yes, he is a student. No, he is not student. And then credit rating here. Here, what is the credit rating here? I am taking the credit rating as a fair or excellent. He is a fair or excellent. And by the computer, the class label here, the by the computer, you call it as a class label here. Here, the first representation. Here, youth, age equal to youth, and then income is high, and then is not a student, and then rating fair. No. Rating is a fair. No. Another important one is youth, high. He is not a student. The credit rating excellent. No, he is not a buying the. He is a youth in the sense he is a 0 to 20 years of age. He is having 0 to 20 years of age. He is not having even though credit rating excellent here, he is not eligible to buying the computer. Here middle age person here, high. He is not student. Fair, yes, he will buy the computer here. And then fourth one, senior. Income is a medium. He is not a student. He is a senior. Income also fair. Credit rating also fair. Even though he will buy the computer. That means for the youth here, he is not a student. He cannot buy the computer. He is not other. That means if it is a youth person, he is a student, then he may buy the computer. For example, comes to the 10th number. 10th row comes to the row number. Row number youth, medium. Okay, 11 comes to the youth, medium, yes, student, yes, credit rating also fair. Even though credit rating fair, yes, you will buy the computer. Why? Because he is a student. Youth is a student. Then you will think that buying the computer. Here, the main issue here, the identification of rows, identification of tuple in a data set. That means identifying the tuple in a data set or the training data set. That is a very important thing here. That is our data set. For this data set here, you will predicting the age, you will developing a decision tree like this. Decision tree at all electronics company. Here decision tree age. Here what is a age is a root node here. Root node or you are call it as an internal node. For the age what? Either youth or middle age or senior person. Yeah, youth. That means the internal node test on a attribute. Here you are performing the test either youth or middle age person or senior person. Yes, the youth, the age equal to youth. Then again you will comes to the student. Here comes to the student here. Yes, student or no. Here he is not a student. No. That means the no means here class label here indicates the buying the computer or not. Yeah, yes, he is not buying the computer. No indicates the not buying the computer. Yes, student. Yes, yes, he will buy the computer. The age equal to youth, he is a student, then buy the computer. Here middle aged person. Yes, even though he is a middle aged person, he is having the more income, then he will buy the computer. Comes to the old age person. The old age person or senior person, but he is in retired stage. That means he is having so many things. That means then yes, credit rating. Based on the credit rating, is buy the computer or not. The credit rating could fail. No, he cannot buy the computer. Credit rating excellent. Yes, he will buy the computer. This is the way of representing. This is a way. Here you have a one doubt is there. Here you have a age is there. How can you selecting the age first? Why not use student first? That means why not take the student as a root node? Why not take the credit rating as a credit rating as a root node here? You have a doubt. Here that kind of information done by using information gain measures. So based on the measures here, the measure the information gain, which attribute having the more information gain, then you will select that attribute first as a root node, and then again selecting the which attribute having the information gain more, that attribute I am selecting as the sub branch root node. That means each and every information, each and every node you call it as root node. And the root node in the sense for this sub branch, the root node is a student. This sub branch, the root node is a credit rating. Here in this way, based on a information gain, you are selecting the this one is a root node, this one is a non-root node. Here for this one, this is an example. Here you have some that means same doubt I am having. A is an attribute, splitting attribute. How can you split that one? A is a splitting attribute here. Here that means splitting attribute A divided into A1, A2, A3. A is a discrete attribute. Discrete values are there. Here, for example, discrete values in the sense age. You, for example, discrete values for the previous data set. Age, youth, young, middle age. These are all discrete values. For example, income, high, low. These are all discrete values. Student, no, yes. These are all discrete value. Buying the computer, no, or yes. These are all discrete value. Here, A equal to A is a discrete value. Or A is a continuous value. Continuous value in the sense splitting point here. Greater than 30 years is a young for the age, greater than 30 years, 30 to 40 years, 40 greater than 50 years, greater than, that means less than 30 years. Less than 30 years indicates that is called here continuous data. And then A is a discrete value, and then binary tree must be produced. Here these are all three the types here. That means I can explain these three types here. If it is A is a discrete value, here A divided into A1, A2, A3. For example, I am taking the color is an attribute. Color what? Color may be red color, color may be green color, color may be blue color. For example, income. In the previous example, income, I am taking the income here. Income is a low, medium, high. Yes, these are all discrete variables here. In this way, you will selecting the attribute values here for the categorical attribute. Attribute values here. Here, income may be low, medium, high. For example, A is a continuous data. Here for this one, A is a continuous data. Continuous data in the sense you will have a splitting point here. For example, A greater than less than or equal to split point. A greater than or equal to split point. For example, income less than or equal to 42,000. Here I am taking the one type of category, and then income greater than 42,000. I am taking the another category. Here A is a binary. Here A is a discrete value and then binary tree. Binary tree in the sense two. Here A is a discrete value here. A belongs to S of A. For example, color belongs to red or green. That means you are having only red. You are taking the red or green only. Yes. That means if it is the color having the red, yes. Color having the yellow, no. Yeah, that means if it is a yes or no, then it will produce a S. In this way, you will split the attribute into different ways. That means depending upon the category. For example, in numerical data, how can you represent the numerical data? It's called here continuous data. For continuous data, age less than or equal to 30 years, just like a youth, and then 30 to 40 years, middle-aged person, greater than 40 years, old-age person or senior person. Here he is a student, yes. He is not a student, no. He is not buying the computer. Then he is a student, yes. He will buy the computer. In this way, for the numerical data or continuous data, I represented in this way. Here you have a algorithm is there. The algorithm for this one here, each and every algorithm consists of input data. What is input data? For the input data, I am taking the data set, attribute list, attribute selection method. The attribute selection method here is either a Gini index or gain ratio or information gain. Whatever we will take any kind of selection method. Here you are giving that means you are giving the any one of the measure here. Here three input data set is one input, and then attribute list also for the data set. I am giving the attribute list. Attribute here previously age, income, credit rating, and this is on buying the computer. Those are all attributes. That means you have to give the attribute list. Not only attribute list, you have to give a attribute selection measure. Here, which one is the best method? And then output here is you have to produce in the dictionary. This is a simple algorithm here. First, create a node n. How can you create the node n here? If tuple in a D are all of the same class. Tuple in a D. For example, tuple in a D in the sense, for example, same class. For example, all are no. Here in the previous data set, for example, in this data set here, some of the class label, class buying the computer, some of them are yes, some of them are no. If all are no, then what is the written n as a leaf node? That means it's simply think as a no leaf node here. If attribute list is empty, then written n as a leaf node. Here two cases are there. First case here is a, what is the first case here? The same class belongs to same class, then written n as a leaf node, and then attribute list is an empty, nothing was there in the attribute list, then written n as a leaf node, and then apply the attribute selection measure. Here what is the necessity of apply the attribute selection measure? Here is a find the best splitting criteria. By thinking I am taking the age first, but that's not a true. You will take the attribute selection measure by taking information gain, highest information gain, lowest information gain, to find the best splitting criteria. To find the best splitting criteria, you are taking the attribute list. Here label n with splitting criteria. Here splitting criteria, here splitting attribute is discrete value. Here splitting attribute discrete value. That means previously I explained the discrete value here. Here for example, color belongs to red, green, yellow. Here belongs to yellow. Attribute list. That means attribute list equal to attribute list. Here attribute list equal to attribute list minus splitting attribute. Remove the splitting attribute here. For each outcome j, splitting criteria. Here in this way you have to identifying the finally identifying the decision tree. This is a algorithm. Here for example I am taking the data set, same data set. Here electronics customer data. For example, this customer data consists of how many rows are there? Here it consists of 14 rows. How many attributes are there? 1 2 3 4 5 6 attributes are there. And then I am selecting the age first. why I'm selecting the age first? I can tell you practically with the help of some label, with the help of some mathematical notation, and then with the help of some WEKA tool, and then with the help of some Python programming, you will selecting the attribute list first. Here I am selecting the age. That means you have doubt. I can explain the age, why I'm taking the age first. I can explain later. I'm taking the age first. Is it youth or middle age or senior? Then it's having, for the youth here, how many rows are there here? It's having 5 different rows. For middle age person, 4 rows are there. For old age person, 5 rows are there. Totally 14 rows. Here 14 rows divided here in this case. Age, here age equal to youth. Whatever may be the age youth. For example, age youth 1 2, and then 8 9, and then 11, and then like that 5 different attributes. I am taking the 5 different attributes here left side, and then middle age person 4 different attributes. Here the attribute selection method is important. Here I am taking the attribute age as a first. How can I take the age as a root node here in this case? Here how can I select the root node as a age here? Here based on the attribute selection methods. Here attribute selection method, the select the attribute with the highest information gain. The first, the select the root node first as the highest information gain. Here there are 3 information gain, Gini ratio, and then Gini index. 3 types of attribute selection methods are there. One is the information gain. They simply call it as a gain ratio, Gini index. Here what is the information gain here? Here ID3 uses a information gain as attribute selection method. ID3 algorithm uses a information gain attribute selection algorithm. Gain ratio, Gini index. 3 different algorithms are there. Here this is a information gain. The information gain you are calculating by using this formula here. Here what is the formula here? First, information of D. First you have to calculate the information of D, and then you have to calculate the information of A. A is an attribute. Attribute may be age, income, information of age, and then gain equal to, or information gain equal to information of D minus the splitting attribute value. That is called here the splitting attribute. Then you will identify the information gain of a particular attribute. Information of gain, information, that is a formula here. Here for this formula, then Gini index. Here how can you calculate the Gini index? Here this is a formula for Gini index. Here information gain measures the bias towards the tests with many outcomes. Here it's having the many outcome, 2 or more. For example, data set equal to true or false, 2 outcomes are there. Here it's having the many outcomes. Then you will use a gain ratio, the split information. Here gain ratio equal to gain of A divided by split information of A. A is an attribute. A may be age, A may be income, A may be anything here. So the splitting information of A is an important thing here. And then Gini index here. Here how can you calculate the Gini index here? Gini of D equal to 1 minus summation I equal to 1 to M Pi whole square. That means here in this case here gain of D. Gini A of D. A is an attribute here. D1 by D, Gini of D1 plus D2 by D, Gini of D2, and so on. This is a way of representing the different attribute selection measures. Very important point here in this case. Here, how can you calculate these measures here? For this one, I am taking a simple example. Here, for this example, how can you calculate the Gini index? Here, with the help, I am representing this information. Yes, Gini index. How can you represent this information? Here how can you calculate this information? Here what are the formulas for this one? I am taking the formula here. I am taking the formulas here. From the formula, how can you calculate the Gini index? Paste it here. Yeah. Here this is a data set. You know how many rows are there here in this data set? 14 rows are there. 14 rows. From the 14 rows, this is a formula for this one. Here, first I am going to calculating the information gain. Here, how can you calculate the information gain? Here, what is the formula for information of D? Information of D. Information of D in the entire data set minus summation I equal to 1 to m pi and then logarithm of pi. How can you calculate the probability value here? Here, pi. Here, data set. What is the data in the data set here? How many labels are there? Here, totally 14 labels are there. How many no's are there? Whether by the computer, no, no's, no, 1, 2, 3, 4, 5, 5 NOs. Here, 5 NOs are there. And then how many yes are there? YESS. 1, 2, 3, 4, 5, 6, 7, 8, 9, 4, 9. 9 different S. Here, the formula here is a minus pi, the probability value here. Here, how can you get the probability value here? Minus pi. Pi in the sense, here you have a for the data here, how many? 9. 9 in the sense, yes. Yeses are there. Yes, buying the computer. 9 indicates that 9 persons buying the computer out of 14. Log 2. 9 persons buying the computer out of 14. That is a probability value. And then minus 5 divided by 14. 5 persons not buying the computer. No. Log. That means that is value is plus log buying the computer. Log 2. 5 divided by 14. 5 indicates here not buying the computer. No value. The class label no equal to 0.940 bits. Here information of age. First I am calculating the information of age. Information of age. How can you calculate the information of age? Here information of A of D equal to summation J equal to 1 to V dj divided by D into information of dj. Here, how can you calculate that value here? For example, no. For the no value, information of age. For information of age, 5 by 14. 5 by 14 in the sense, 5 J in the sense here, no value. That value 5 by 14 into 2 divided by 5. How many not buying the computer value here? How many not buying the computer? 5. Out of 5, here the value dj divided by d. Dj divided by d here is a dj2. Out of these values here, buying the computer 2 persons. 2, what is a 2 here? 2. For example, if it comes to the data set here comes to the data set, youth, no. Youth not buying the computer, no. Here is a senior person, yes. Here is a youth, is a yes. And then senior person, other one senior person. Youth and senior person, 2 persons are there here. Here, what is the thing here? 5 by 14 in the sense, total number of 5 by 14. That is a formula according to formula 14. And then into here, what is the value here? 2 by 2 in the sense, it may be senior person. The senior person not buying the computer into log. And then what is the 3 here? Youth not buying the computer. 3 not buying the computer plus 4 by 14. Here 4. What is the 4 here? 4 in the sense, the persons. How many middle-aged persons are there here? The middle-aged person 1, 2, 3, 4. 4 members are there. In the 4 members, middle-aged person yes, middle-aged person yes, middle-aged person yes, all are yes. Here middle-aged person all are yes. Here the value here 4 by 14. Middle-aged person 4 by 4 log 2 minus 0. Nothing was there, 0. You cannot represent that value here. Here also you will represent the 0 by 5 like that. And then 5 by 14. Here 5 by 14 indicates the, what is a 5 by 14 here? In this case here, senior persons are there. Here 5 by 14, the senior. Here in this way, you will calculate the age. For the age, information gain. Age equal to senior person, age equal to youth, age equal to young person. Here, for based on the age only, I am calculating the information age equal to splitting value here 0.692. Here, therefore, gain of A equal to the formula here is a gain of A equal to gain of that means not a guinea here. Here gain, here the formula for the gain here is a gain of A equal to information of D minus information of A in the sense attribute equal to what is an attribute here? Age. Here finally the gain here, gain of A is equal to information of D minus information of age of D, that is equal to 0.940 minus 0.69 694 equal to 0.246 bits. Here the gain of age equal to 0.246 comes to the gain of age equal to 0.246 bits. And then similarly, if you apply the same formula for the income, if you apply the same formula for the student, if you apply the same formula for the gain ratio, then what are the I applied that one and then find the values here. The gain of income equal to 0.029 bits, and then gain of student equal to 0.151, and then gain of credit rating equal to 0.48. In this all cases, what is the more value gain? Here, what is the more value for the information gain? More value for the attribute. Here comes to the age. If it comes to the age, 0.246 bits. That's why the age of the data set, that age here, I am here, the age has a highest information gain. The age has a highest information gain. So I am selecting age as a splitting attribute. Is it clear or not? That means you have in the previous session, you have a doubt is there. Here, why you are selecting the age? Why not income? Why not student? Like that. Here, because of age having the highest information gain. In this way, you will calculate the information gain. Here, what is the necessity of information gain? Splitting the attribute, identifying the root attribute for this one. Here, this is a, that's why here in this case, I am taking the age. I am taking the age as a root attribute. From the root attribute, it is a youth, age equal to youth, age equal to middle age, and then age equal to senior. Here, and in this way, you are selecting the age value. Next, which attribute selecting for the youth? Here, youth having the income, and then student credit rating. Here, which attribute you are selecting? Here, next highest one having the 0.29 income, 0.151 student, 0.151 student. That's why left side here after youth you are selecting the student. If it is a student, yes, the class label equal to no. If it is a student, no, the class label. Youth is a student, yes or no? Is a student, no, no. Is student, yes. That's why in the left side I am taking the student here. For the middle age, no need to take the student here. All yes, that means the one thing here, all class labels are same. You will that is a one of the point here. All class labels are same. That means no need to go for the splitting. That means itself is a leaf node. And then middle age person, or that's a middle age person. If it comes to the senior here, if it comes to the senior, what is the senior information? We are taking the next information gain. Here for the senior, okay, age over, student over, next income. We are taking the income value. Income is a low, income is a high, and then you have to calculate again credit rating also. In this way, you will, that means in this way you will dividing the data. After dividing this value, what is the result here? Result appear like this. The result here, appear like this. Age. That means in this way, I am taking the age value student. I am taking the credit rating value student. I am taking, that means I am not considering income here. Very less information gain. That's why I'm not considering the income in this case. In this way, based on the information gain, I am taking. That means Yeah, based on information gain. That means information gain is one of the criteria for one of the measure for selecting the attribute. Here, that's a selection of attribute here. In this way, you are selecting the attribute here. Other important one here is a okay. You are selecting the attributes and then draw the tree. You draw the tree. Here, tree pruning methods are there. Here, what are the tree pruning? Pruning in the sense cutting methods. Here, the pruning algorithm attempt to improve the accuracy by removing tree branches, reflecting the noise here. If there is a noise here, how to remove that noise in a tree? Yes, how can you remove the noise in a tree? Here we have two methods are there. Free pruning method. Before constructing the tree, you have to early pruning, halting its early construction. That means prune the early construction, and then post pruning here. After constructing, here fully grow the tree. That means removing its branches and replacing it leaf node. That means any the subtree at a given node is pruned. A subtree at the given nodes is pruned by removing its branches here. That is a different pruning methods here. Here the pruning methods can't uses a complexity algorithm, number of leaf nodes plus error rate. And then C4.1 uses a the pruning like a cost complexity for the error rate calculation. Here this is a way. For example, how can you prune this one? Here what is the noise in this case here? For example, a1, a2, a3, a4, and then a5. A5 is there. Here in this case, if you treat the a3 is a a3 a5 are the noise for this one, remove that one, place the class label here. In this way you will prune the unpruned tree, prune tree. Here that means removing the some of the branches. If it having the noise, that is a decision tree construction. Here same, that means taking the decision tree is not a simple very complex thing here. That means you have to consider the all attribute value as selection measures, and then how can you which attribute selecting first, which attribute selecting next. That means all these cases also you should consider. Here are scalability and decision tree induction. The scalability measures are there. The scalability, repetition, replication. Here it's having the repetition. Here replication, some what is the scalability and decision tree methods here? The efficiency, identifying the efficiency here, you take the scalability. And then SQIQ, supervised learning in first. And then sprint, a scalable parallel classifier for the data mining. Rainforest, very important method here is attribute value and class label. Bootstrapping, optimistic algorithm for tree. These methods are scalability, scaling. How can you extend this one? Scaling, reducing the size or increasing the size. The repetition, what is the repetition here? Here repetition, a1 less than 60, a1 less than 45, a1. That means here items, repeated items are there here. Here the attribute a is repeatedly tested along a given branch of the tree. That is called here a repetition. Here you have to remove the repetition here. For example, replication here. Here come to the replication here. The replication here where the duplication of subtrees. You identify the different repetition and replication. The repetition in the sense the attribute value repeatedly occur. The attribute value repeatedly occur. Here replication in the sense here the sub branches are there. For example, in this case here, for example, credit rating. Credit rating, excellent, income, low, middle, high, a fair, class level A. Similar branch appear here. You have the similar branch here where the duplication subtree exist within a tree. Such a subtree headed by the credit rating, headed by the node credit rating here. Here more number of times the sub branches occur. That's called here replication. You have to remove the replication in a tree. And then SQLite. That means it is a supervised learning in a quest here. In this case here, your data set subdivided into disk resident attribute list and the memory resident class list. Here in this case here, the credit I'm going to credit rating excellent. Here RID 1, here 38 age, divide subdivide division is there, and the RID 1 here. In this way, in 5, the node here by the computer, yes, the node here indicates the 5. In this way you will apply the supervised learning in a quest, and then sprint scalable parallelizable, in induction of decision tree is a scalable parallel classification approach. Here uh, yeah, Sprint uses a different attribute list data structure that holds the class and RID information. Here, when a node is split, the attribute list are pruned and dist distributed among the resulting nodes. This is another important one. And then rainforest. The rainforest is one of the main important, uses a data structure to hold the aggregate information regarding the training data. Here it can be, for example, here you age equal to youth, middle age, and then senior by the computer, and then income based on income by the computer, based on the student. That is called here rainforest information. Here it uses a data structure to hold the aggregate information regarding the training data set, or one approach to improving the scalability of decision tree induction. It is one of the improving method, scalability. And then other one is a bootstrapping optimistic algorithm for tree. It uses a several subset. Here, trees are constructed for each subtree of our sample. Finally, T is formed based on a all tree. This tree is very close to tree generated from the original training data had fit into the memory. Bootstrapping optimistic algorithm for tree uses attribute selection methods here. Here, three methods are there: information gain ratio, like that. It will use some of the method. Here, advantage, it is a faster than the rainforest. It uses a incremental updates, reflect any insertions or deletions. Here, these are different examples here. This is a this indicates that decision tree. Here you have a decision tree. How can you practically apply the decision tree? That means by taking the WEKA tool, I can implement this information using decision tree. Here comes to the WEKA tool. WEKA tool has a different application here: Explorer, Experimenter, Knowledge Flow, and then Workbench, and then GUI. Here I'm taking the Explorer. Comes to the Explorer. Click on Explorer. Click on Explorer. Here, if you click on Explorer, then it displays the information like this. It displays the table data like this. Here it consists of preprocessor, classify tab, cluster tab. That means all operations performed by using WEKA tool here. Cluster tab, and then associate tab, and then selection attribute here. Here, for this one, I am taking the data set. Here I am taking the data set, same data set. Here, for example, all electronics customer database data set. Here the data set, here I am selecting the file. Already I prepared that file, customer data set. Here if it comes to the data, here you have a different data sets are there. Here from this data set I am taking the decision tree data set. Here all are in a .arf format or .csv format also there. CSV, yeah, CSV format is there, and then I am taking the decision tree. Here the decision tree consists of just like a previous decision tree induction methods. Here previous decision tree induction methods. Here this is a decision tree sample data. This is a decision tree. I prepared the same data. Yeah, here comes to here. I prepared same data. Data consists of RID, age, income, student, and then credit rating, and then class is a by the computer. Here, if you edit here, what is the data set? The data set consists of values like this. The data in this data set, values are, what are the values here? RID, age. Here it will use the numeric data RID, nominal attribute, income nominal attribute, student nominal attribute, credit rating nominal attribute, and then same. How many rows are there? 14 rows are there. From the 14 rows, I am going to draw the decision tree. Here I am going to drawing the decision tree here like this. Here this is a data set. I am preparing the data set here. Here comes to the data set. Here I am going to applying the classify. Click on classify tab. Why? Because decision tree is a classification algorithm technique. Here use training set, training data set. Here select the one of the algorithm here. For example, it's a WEKA classifier. They are classified base algorithm based things are there, base, and then function, different functions are there here. Logistic function comes to different rules. Here you will apply the rule. Decision table rules are there, and then trees comes to the trees here. Here decision stumping, and then any tree algorithm you may apply here. For example, random tree algorithm, and then then means I am taking J48 algorithm. Here you may use a training data set here. Here J48 algorithm. This algorithm consists of here uh, batch size, here splitting value, and then tree, collapse tree, and then factors, debugging information, like that, speed, and then pruning, pass, not applying anything. Here in this way, the class for generating a pruned or unpruned C4, C4.5 algorithm. Here comes to the here start. Here it will generate a some information here. Here what is the information here? The information consists of here attributes are there. Totally 6 different attributes, and then J48 prune tree here. Age equal to youth. Here comes to the different information. Age equal to youth. Here what is the thing? Yes. Age equal to student. The age equal to youth, student. Yes. Yes. Student. No. Age equal to middle age. Yes. By the computer. Age equal to senior. Credit rating, based on the credit rating, fair, yes. Based on the credit rating, excellent, no. Yes, that is a case here. That means in this way, number of in this case, number of leaves equal to 5. Total number of leaves. How many leaves for this tree here? The size of the tree, 5. The size here, and then in this way, the values, the detailed accuracy by this classes. Accuracy also, you are identifying the accuracy. Here how can you see the construction of tree? Here right click on here, visualize the tree. Here visualize the tree here. Here this is a tree. That means I'm telling you, this is a tree representation. Here this is a tree. In this tree here, you will identify the different class labels. Here for example, age equal to youth. Here practically it will show the decision tree. That means I am giving the data set to the algorithm. That algorithm learn based on the next time. If I give any data, the algorithm produces a great result. The algorithm produces a result here. For example, I am giving the okay. Okay, I'm giving the, for example, buying the computer, yes. Buying the computer, no. Here this is a class label. Buying the computer, no. Then that means if you give the, again next time, if you give the this information, it will generating different rules here. Here these rules, from these rules here, it will generating the decision tree. Here the decision tree appears like this. Here this is a decision tree. It will generate the decision tree. age. That means that means I am using here in this case information gain. Why I am using J45 information gain, the selection method. That's why why I'm selecting the age first here. Why? Because the age having the highest information gain. That's why I'm taking the age as a root node. After that, student, youth, the age equal to middle age equal to senior, the age equal to youth, the student, the student. Why I'm selecting the next student here? The next student having the highest information gain. That's why I'm selecting the this student here. Student, no, no. Here you are identifying the some of the information here. What is the information? No, bracket having the three in the sense, what is the three? How many number of no's for the student? No, how many number? Three number of no's. So if you calculate the total value here, the total value of 14. 3 plus 2 5, 5 plus 4 9, 9 plus again 5, totally 14. The 14 values are there. That's why the no, how many no's? 3 no's for student. No, in a based on the data set only it will calculate. If you take the data set, more data set values, it will calculate here. Yes, how many values are there? 2. For example, middle-aged person, how many middle-aged person values are there? 4. In this way you are calculating the different values for the data set. This is a something, that means it is a practical approach here. The next one here is a, this is a decision tree, very important decision tree. Bayes classification measure. Bayes classification. Bayes classification. What is the Bayes classification? This is a, and then how can you apply the Bayes classification approaches?